Hello, in this lesson, let's cover the definitions of conduction, convection, and radiation. Let's start talking about conduction. So conduction happens when two or more materials are in contact with each other and there's a difference in temperature between them. In the microscopic level, what happens is that we have some particles that are in contact in the material, and each particle transfers its energy to its neighbor particle. We can calculate the heat transferred by conduction using this expression here, where we have a constant that depends on the material, that's the thermal conductivity of the material. We also have the area, the contact area between these two materials, the difference in temperature, and the thickness. As I told you before, this constant K depends on the type of material. So the higher the value, the higher is the heat transfer. So we say that these materials with high values of K are good conductors, and on the opposite side we have good insulators. So the lower the K, the best it's the insulator. Talking now about convection. Convection is driven by large scale flow of matter. So basically we have a variation in temperature that causes a variation in volume, and this leads to a variation in density, and this variation in density creates convection currents. For example, in the air, if we heat the air, we have this variation in temperature. The hot air has a lower density and it tends to go up. On the other hand, if we cool the air, we have this variation in volume, so we have a bigger density, and the cold air tends to go down, and this creates these convection currents. We can calculate convection using the heat transfer and phase change formulas. Some examples are the convection currents in your fridge. So you have the freezer that's colder, has a colder temperature, and the fridge down here that has a higher temperature than the freezer, so we have some convection currents occurring here. The same in the inside of our planet, because of the difference in temperature between the core and the lithosphere. Also in our atmosphere, because of the difference in temperature, the variation temperature of our planet and the space. Now, the third type of heat transfer is by radiation. This one, we do not need a medium to transfer the heat. So the hot body emits electromagnetic waves that are absorbed by another object. And we can calculate this heat transfer using the Stefan-Boltzman law of radiation, in which the heat transferred is the Stefan-Boltzman constant times the emissivity times the surface area times the temperature, the absolute temperature, in state 2 to the 4th minus the absolute temperature in state 1 to the 4th. A very common example is the radiation, the heat transferred from the sun to Earth, where the sunlight reaches the Earth by radiation. Some of this radiation is reflected back and some is trapped by the atmosphere. Alright, now it's your turn to think about it. So imagine this system here, as you see in this picture. We have a hot plate with fire, a pan, and a water that's starting to boil. So can you tell me what types of heat transfer you see in this image and where they are occurring? So think about it. and comment your answers in the comment section.
Hey guys, thanks for watching this video. We love helping you learn. Be sure to subscribe and watch some of our other videos, and stay geekly, my friends.